calculate the center of mass of a solid hemisphere. So we have a solid hemisphere of mass capital M and radius capital R. Now to consider, and this is symmetric about y-axis. So if it is symmetric about y-axis, center of mass, basically x coordinate and z coordinate are going to be 0, 0, right? So we just need to calculate YCM. And what is YCM? The formula is 1 by m integration y dm. So what is y? So first we will go here. So we are going at y height. Okay, so we are going at a particular y, then taking a section which is having a width dy, right? And now basically what will that form? So this is a solid hemisphere. If we cut it like this in slices, this is going to be a disc, right? So a disc at y height, and the thickness of the disc is basically dy. Now where the center of mass of this disc lie is somewhere over here, because it is the full disc and center of mass lie exactly in the middle. Now y is nothing but y, because we have went up to y height and center of mass lie there. So that is the position of the center of mass where this dm lies. And what is the dm? Dm is basically mass of that disc. How do you find mass? So total mass divided by total what? Volume, because the mass is distributed in a volume, right? So total mass of a volume. So what is the volume formula? 4 by 3 pi r cube is the volume of full, right? The complete solid sphere. So here it is going to be 2 by 3 pi r cube is equal to required mass, which is dm, divided by required volume. So how do you find the volume of this disc? So volume of this disc is going to be the area. So what is the radius? Here radius is, let's say, r. So area is going to be pi r square, area of this area, into width. What is the width? Width is like dy. So into width, so that is dy, and that is going to be our volume. To be precise, the small volume, I am calling it dv. Now what is this r? So if you relate over here, so this is r radius, this is y, and this is capital R. So I can apply Pythagoras theorem, and I can say that this y square plus r square is equal to capital R square. We need this r square. So this is going to be pi capital R square minus y square dy, right? So this is going to be our volume. And now this is what we need to put it over here. So pi r square minus y square dy. And now let us cancel whatever we can. So this gets cancelled and this goes here. So we get our dm equals to 3m r square minus y square dy divided by 2r cube. So this is the dm, this is my y. And now let us integrate y. Y varies from where to where? When y was 0, we were getting the base. And when y is r, we'll get the topmost layer, right? So y changes from 0 to all the way up to r. So let us do this integration. So this is 1 by m integration y. Dm was 3m r square minus y square dy divided by 2r cube. Let us take the constant outside. What were the limits? Limit was y was varying from 0 to r. And now take things outside. So m is cancelled. This is constant, will come out of the integration. This 2r cube is also a constant. This 3 is also a constant. And this y is going to be multiplied. So r square y minus y cube dy. This is what we need to integrate. So let us integrate 3 by 2r cube. Integration of this is going to be r square, which is a constant, y square by 2 minus y raised to 4 by 4. Put the limits 0 to r. Putting the limits, we get, first put r over here. So r raised to 4 by 2 minus r raised to 4 by 4. And when you put 0, you get basically 0. And now let us solve this. So this is basically half minus 1/4, so which will give you 3 by 2 r cube times r raised to 4 by 4. So cancel this r cube with power 4. We get 3r by 8. And that is going to be our y coordinate of center of mass. So we can say center of mass of a solid hemisphere lie at a height of 3r by 8. That is going to be our y coordinate of center of mass. What about x and z? X and z are 0 due to symmetry. So this is y coordinate of center of mass is 3r by 8. That is what you need to remember. Let us find the center of mass of a hollow hemisphere. So we have a hollow hemisphere of mass m and radius r. So now again we want to get the center of mass, and this is symmetric about y-axis. So x coordinate and z coordinate are going to be 0. And what about YCM? For YCM, we have this formula 1 by m integration y dm. Same formula we have to apply. And it is just, we need to write what is y and what is dm. So what is dm? So here I am going at an angle theta, and I am considering an element, which is basically the width of this element is going to be r d theta, right? And then I am going to cut it like this. So what do you get? You get a ring like this. And what about this ring? So let us say it has a radius small r. And what about the width of the ring? This width is nothing but r d theta. So what about this small r? So this angle is theta. So this angle is going to be, so what about this? This is r cos theta and this is r sin theta. So we can say that our small r is nothing but r cos theta. And what about y? The y is this center of mass of this entire ring. This is a ring. Center of mass will lie at the center. So center of mass is lying over here, and this point is here, which has a height of r sin theta. So our y is what? R sin theta. What about dm? Dm is mass of this ring. How do you find? Here, this is a hemispherical shell, and for a shell, the mass is lying over an area. So basically total mass, that is capital M, divided by total area. What is the area of a sphere? Surface area 4 pi r square. This is a hemisphere, so it is just 2 pi r square is equal to the required mass, that is dm, divided by the area of that dm. What is this area? So this is a ring, right? When you cut it, you get 2 pi r. So 2 pi, that is the length. And what is the width? Width is r d theta. And what is this r? This r is r cos theta. So here I can write 2 pi r cos theta into r d theta. So now this 2 pi gets cancelled. In fact, r square gets cancelled. And now we can say that dm is nothing but m cos theta d theta. So we know that our dm is m cos theta d theta, and y is basically r sin theta. And we need to put the limit where we have a variable theta. So theta varies from where to where. When theta is 0, this is covering this ring. And when theta is 90, it is covering this ring, right? So theta varies all the way from 0 to 90 degree, that is pi by 2. So let us integrate it. Formula is same, 1 by m integration. What was y? Y was r sin theta. What was dm? Dm was m cos theta d theta, right? And when we integrate, so first is basically r will come out, divide by m. This is sin theta cos theta, and this m also will come out. So this is sin theta cos theta. What if I multiply and divide with 2? So when I multiplied and divide with 2, I get 1 2 over here, and this 2 I am utilizing over here. So it becomes 2 sin theta cos theta and d theta. Limit is 0 to pi by 2. What is 2 sin theta cos theta? That is the formula, sin 2 theta, right? So this is m gets cancelled, r by 2 integration of sin 2 theta d theta, 0 to pi by 2 is the limit. Integration of sin 2 theta is basically minus cos 2 theta by 2. This is the integration. And this r by 2 as it is. And now put the limit 0 to pi by 2. So when you put pi by 2 over here, you get r by 2 minus this 2 also you can take out, so it becomes 2 over here. So this is minus cos of pi by 2 into 2, that is pi, minus of minus, which is plus, cos of 0 into 0 into 2 into 0, that is 0. So this is 1 and this is minus 1. So this minus of minus 1 and 1, that is 2. And 1, 2 gets cancelled out and we get r by 2 as answer. So what is the YCM? YCM is r by 2. Final conclusion is that y coordinate of center of mass is r by 2. So for a hollow hemispherical shell, center of mass lie at r by 2 height from the center, right? Now, center of mass of a solid cone. So center of mass of a solid cone is basically found at a height of 3h by 4. So from the height, if the total height is h, then this is 3h by 4. This is where it lies. What about r? Why r is not in the equation? So r is the radius of the base. R is not going to affect the position of center of mass as about y-axis. Again, it is symmetric. So xcm and zcm are 0 and only ycm you will get, and y is only given by the height.